In August of 1992, the Atlantic hurricane season had produced exactly one named storm through its first 73 days. One. Andrew, in late August, would become the season's most destructive storm. But before Andrew, the season had been historically quiet. News coverage had moved on. Emergency managers in South Florida were not running peak season readiness drills. And then a tropical wave emerged from the African coast, crossed the Atlantic largely unnoticed in a period when the public and much of the emergency management community had concluded that 1992 was going to be a quiet year. And on August 24th, it made landfall near Homestead, Florida as a Category 5 hurricane with 165 mile-per-hour sustained winds. In today's dollars, Andrew caused more than $65 billion in damage. It is still the strongest hurricane landfall in Florida history. And the season that produced it had, through August 10th of that year, fewer named storms than 2026 has today. Today is August 12th, 2026. The 2026 Atlantic hurricane season has, through yesterday, produced 2 named storms in 73 days. The public narrative of this season has been built around one concept: El Niño suppression. Below average. Quiet. The forecasts were right. Below average through day 73. What the forecasts and the coverage have not adequately communicated is the specific mechanism by which a below-average season that feels essentially dormant can suddenly, in a matter of hours, produce multiple simultaneously developing systems in the deep tropical Atlantic, the spawning ground of the most powerful hurricanes in history. As of this morning, there are 3 named or near-named storm systems in the Atlantic simultaneously. A potential tropical cyclone in the northwestern Gulf of Mexico bearing down on the Texas coast. Invest 92L in the central Atlantic with a 70 to 80% development probability and a tropical depression expected within 2 days. Tropical Storm Cristobal, already named as the season's 3rd storm, moving eastward away from the United States. And behind all of these, a detail that most of the coverage this morning has not yet absorbed: DeepMind's machine learning atmospheric model. The same GraphCast system that accurately forecasted Super Typhoon Baby's peak intensity when the official forecast guidance was more conservative is highlighting a separate system that the NHC has not yet tagged. Not Invest 92L. A different wave behind it, which DeepMind's ensemble is developing for what meteorologist Tomer Berg specifically described as long-track development. Long-track development. That phrase carries specific meaning in tropical meteorology, and I want to explain it carefully, because it is the phrase that connects what is happening in the deep Atlantic today to the most catastrophic hurricane events in modern history. A long-track storm is one that develops from a tropical wave in the deep tropical Atlantic, east of roughly 60 degrees west longitude, and sustains itself across the full width of the Atlantic basin before reaching the Caribbean or the U.S. coast. These are the storms that spend 10, 12, 14 days crossing open ocean, intensifying in the deep warm water of the main development region, gaining enormous horizontal extent, and arriving at their target coast as fully mature systems carrying the full energy of a seasoned hurricane. They are called Cape Verde storms because they typically develop in the waters near or west of the Cape Verde Islands off the African coast, carried westward by the trade winds from their birthplace in the convergence zones off West Africa. The historical record of what Cape Verde storms have done to the Americas is the specific reason that the phrase long-track development in a forecast discussion is taken seriously by anyone who understands what it represents. Hurricane Hugo, in September 1989, was a Cape Verde storm. It developed off Africa, crossed the Atlantic, devastated the Lesser Antilles, and made landfall in South Carolina as a Category 4 hurricane that killed 57 people in the U.S. and 49 in the Caribbean. Hurricane Andrew in 1992 was a Cape Verde storm. Hurricane Floyd in 1999, which produced the worst flooding in North Carolina history, killing 57 people and inundating more than 30,000 homes, was a Cape Verde storm that tracked from the deep tropics all the way to the Carolina coast while maintaining a size equivalent to the state of Texas at its peak extent. Hurricane Ivan in 2004 was a Cape Verde storm. It crossed the entire Atlantic basin, struck Grenada as a Category 3, Jamaica as a Category 4, the Cayman Islands, with catastrophic storm surge, Cuba, and then made landfall in Alabama as a Category 3 after having briefly reached Category 5 intensity with 165 millilauster winds over the western Caribbean. Ivan produced 117 tornadoes across the eastern United States after landfall, one of the largest tornado outbreaks ever associated with a landfalling hurricane. The 2004 season is notable specifically because it produced 4 major hurricane landfalls in Florida within 6 weeks. Charlie, Francis, Ivan, and Jean. 3 of those 4 either Cape Verde systems or Cape Verde origins. The destruction across Florida that season, $45 billion in total damage, was driven by a wave train that activated in August and sustained itself through September. The wave train activating right now in the Atlantic today is the same African easterly wave mechanism that fueled 2004. Let me explain that mechanism, because understanding where these waves come from, physically, not just geographically, tells you why the activation of the Cape Verde wave train is categorically different from the Gulf and Western Caribbean development that has characterized the 2026 season's first two named storms. The African easterly jet is a current of air at mid-levels of the atmosphere, roughly 10,000 to 15,000 feet above the surface, that flows from east to west across West Africa and out over the Atlantic. It exists because of the temperature contrast between the hot, dry air mass over the Sahara to its north and the cooler, moister air mass over the West African rainforest belt to its south. Where these two air masses meet, the temperature gradient drives the jet. And because that temperature gradient is sharp and the atmosphere in the zone is dynamically unstable, the jet breaks down into organized disturbances, ripples and waves that propagate westward off the coast of Africa and into the tropical Atlantic at the trade wind latitudes. These are the African easterly waves. They are the seed disturbances from which the majority of major Atlantic hurricanes grow. Research has consistently shown that roughly 85% of intense Atlantic hurricanes originate from African easterly waves that cross the Atlantic from the African coast. The waves that don't develop, the ones that shear apart in hostile atmospheric conditions or get dried out by the Saharan air layer or encounter an unfavorable sea surface temperature environment, are the quiet background of tropical weather that happens every summer whether or not anyone notices them. The waves that do develop, in years when the atmosphere is favorable, become the ones that define hurricane seasons in the historical record. The 2026 season's quietness through August 11th was not a lack of waves. The African easterly jet produces waves continuously throughout the summer. It was a consistent suppression of the waves that were present by the combination of El Niño shear over the tropical Atlantic, Saharan air layer dryness, and an unfavorable MJO phase that kept atmospheric humidity low and upper-level outflow from tropical systems constrained. Every week this summer, waves came off Africa. Every week this summer, they encountered conditions that prevented them from developing into named storms. The season looked quiet because the suppression was working. What Dr. Ryan Maui described in this morning's forecast discussion as a conveyor belt of tropical energy becoming active is the specific moment when the seasonal balance between wave production and wave suppression shifts. The El Niño shear is still present. It has not disappeared, but it has weakened somewhat from its peak. The Saharan air layer has thinned over the deep tropical Atlantic as the summer progresses. The SAL's annual life cycle is worth understanding briefly here, because it is part of why Cape Verde activity is typically concentrated in August and September rather than June and July. The SAL is most intense in early and midsummer when Saharan dust export peaks, and the resulting dry, dusty layer over the tropical Atlantic is thickest. As summer progresses, the West African monsoon trough advances northward, reducing the dust export and allowing the SAL to thin progressively. By August, the SAL is significantly less effective as a development suppressor over the deep tropical Atlantic than it was in June. The clean, moist air needed for deep convection can extend to higher altitudes. The mid-level dry entrainment that kills developing storms weakens, and the thermal inversions that cap convective growth become less pronounced. The combination of thinning SAL, weakening El Niño shear, and favorable MJO phase creates the specific August window in which Cape Verde development has historically concentrated. That window opened this morning. Invest 92L is the first wave that has survived long enough to receive official NHC monitoring. It is in the central Atlantic near 11 degrees north, 36 to 37 degrees west, approximately 2,000 miles east of the Lesser Antilles. A 1011 millibar low center has been identified at this location. The NHC's official language is that a tropical depression will likely form within a couple of days as the system moves westward at 10 to 15 knots. At that speed, covering roughly 200 to 300 miles per day, the system arrives at the Lesser Antilles in approximately 7 to 10 days from today. The track solutions on the model ensemble spread between a Caribbean penetration path through the Windward Islands into the Caribbean Sea, and an Atlantic arc path that stays north of the Lesser Antilles and tracks toward the Bahamas corridor. The system that DeepMind is highlighting behind Invest 92L is the more alarming element for the longer range forecast. And I want to be precise about why. A long-track Atlantic system that develops from a wave near the Cape Verde Islands and maintains its intensity across the full tropical Atlantic arrives at the western end of the basin, carrying more total energy than a system that forms in the Gulf of Mexico or the Caribbean. It has had more time and more ocean to fuel itself. It has had more time for its circulation to organize, and for its inner core to develop the compact, intense structure that makes landfall impacts catastrophic. Ivan, in 2004, killed more than 90 people in the Caribbean and caused $14 billion in damage in the U.S., despite a track that was actively monitored for weeks before landfall. precisely because Ivan arrived as a fully mature Category 4 hurricane carrying the full organizational energy of a storm that had been intensifying for 2 weeks. The lead time was there. The preparation was adequate. The storm still produced the damage it produced because of what it was when it arrived. If the system DeepMind is tracking behind Invest 92L, develops as the AI model suggests, if it achieves tropical cyclone status and maintains its organization across the tropical Atlantic, it would be on a track that places it in the Caribbean or the Gulf in the window of approximately 2 to 3 weeks from today. That is the outer range of meaningful forecast guidance, but it is also the window in which preparation decisions that cannot be made quickly are made or not made. Evacuations of vulnerable populations in the Caribbean, particularly in island communities with limited evacuation infrastructure, supply prepositioning for island territories, review of hurricane shelter availability in coastal communities along the Gulf and the U.S. East Coast. These decisions, if made 2 weeks ahead of an impact, produce better outcomes than the same decisions made 48 hours ahead. The third system currently developing, potential Tropical Cyclone 1, which is expected to become Tropical Storm Arthur in the Gulf of Mexico today, is the least surprising of the three in terms of the physics involved. Gulf systems that develop from frontal boundaries and subtropical troughs during August are a known and documented occurrence. What is notable about this system is not its mechanism, but its timing. It is forming simultaneously with the Atlantic's first significant Cape Verde activation of the season, and it is doing so in a Gulf of Mexico, whose ocean heat content I have described throughout this series as near record in terms of warm water depth. A Gulf system forming under these conditions has the same intensification potential that Bertha had in late July, the same loop current eddy background, the same deep warm water below the surface. This specific potential tropical cyclone is expected to remain at modest intensity before moving inland over Louisiana tonight. But the Gulf conditions that exist right now do not change between this system and the next one. The 1992 Andrew analogy is not perfect. It never is. Andrew developed from a wave that was less well observed in real time than modern systems are, in an era before satellite data of this density and model resolution of this quality. If Andrew were forming today, GraphCast would have flagged it. The half-say model would have predicted its rapid intensification. Shake Alert, the earthquake early warning system, is irrelevant to hurricanes, but the analogous intensity forecast improvement over the past 30 years would have given Florida more time to prepare for Andrew's 165 millimeter with Eric's landfall than the 1992 population received. The point of the Andrew comparison is not that the same storm is coming. The point is that the category of storm, a deep tropics long-track Cape Verde system, is what the current wave train activation makes possible. And it is a category that the quiet early season narrative has discouraged people from thinking about. The 2026 season is not going to match 1992's total storm count. El Niño's suppressive effect on the overall season count is real. But 1992 produced Andrew from one of the season's 7 total storms. The 2026 season, which is now producing multiple simultaneous developments as the wave train activates, does not need to produce a dozen storms to produce one that matters. It needs to produce one Cape Verde wave that finds the right conditions at the right time. The record warm Gulf of Mexico that I have covered throughout this series provides the intensification environment for any system that reaches it. The record deep ocean heat content means any such system has a below normal likelihood of encountering the cold water upwelling that normally limits rapid intensification. And the El Niño that has been suppressing Atlantic activity is simultaneously the same El Niño that warmed the Gulf to near record depths. The suppression and the fuel exist in the same atmosphere at the same time. What changes is which one is winning on any given week. And on August 12th, 2026, the fuel is winning, the wave train is activated, the quiet season is no longer quiet. And if 1992 is any guide, the storms that form in the second half of an El Niño hurricane season's quiet opening can be the ones that define it. The August 12th activation of multiple simultaneous systems in the Atlantic Basin marks the specific transition from the El Niño suppressed early season to the MJO-enabled active period that the scientific record for super El Niño years shows as the characteristic pattern. The quiet was real. The current activation is also real. Both are parts of the same atmospheric story. Understanding that story is what allows you to prepare for what the second chapter looks like, rather than being caught by it in the way that Homestead was caught by Andrew in August 1992. In a year that everyone had decided was not going to be a hurricane year. For anyone along the Gulf Coast, the Caribbean island chain, or the U.S. East Coast, the monitoring period that matters most begins today and runs through the first week of September. What develops from the current wave train and where it goes will be determined over the next 14 days. Those 14 days are the preparation window, the specific period in which hurricane shutters can be installed, Hurricane supplies can be purchased without competing with a panicked citywide buying rush. Evacuation routes can be reviewed and confirmed, and hurricane insurance can be verified as adequate. Once a Cape Verde system is 5 days from the coast, the preparation options narrow dramatically. Shelters fill, supplies sell out, fuel lines form. Evacuation routes congest. The 14-day window is not a luxury of time. It is the window in which preparation is orderly and effective, rather than frantic and partial. The specific communities I want to reach with this video are those in the Caribbean island chain, Puerto Rico, Hispaniola, the Lesser Antilles, Cuba, Jamaica, and the Gulf Coast states from Texas through Florida. These are the communities that sit at the end of the travel path of any Cape Verde system that develops from the current wave train. They are also the communities that the quiet early season narrative has most effectively lulled into reduced vigilance. The 2026 season produced 2 named storms in 73 days. The Caribbean had nothing to manage. The Gulf had Bertha in late July and quiet since. The natural psychological response to that history is a reduction in alert posture. The 1992 Andrew parallel is that Andrew arrived into exactly that psychological environment, a region whose emergency management posture had relaxed during a quiet season. Homestead, Florida had 12 hours to prepare for a Category 5 hurricane. Preparation done in 12 hours is categorically inferior to preparation done 2 weeks in advance. The wave train is now active. 2 weeks of preparation time begins today. I will be tracking every system in this activation daily and reporting back whenever the forecast picture changes in a way that warrants immediate attention. Subscribe and turn on notifications. Thank you for watching. I will see you in the next one.